Hi guys, in this video we're going to talk about geometric transformations. In this particular video we're going to talk about translations. First we're going to talk about what rigid motion is, then what translations are, then we're going to do a couple of examples. In simple terms, rigid motion is just moving a shape around a graph without changing its size. So in this case, like, I could slide this across, or what I could do is I can rotate it, and the dimensions or the lengths of the sides and the sizes of the angles do not change. We call that rigid motion. So now let's take a look at what translations are. So what a translation is like a slide or movement where the shape is reproduced in another location on a graph, but is simply just moving. So something like that, or like this. We can also move diagonally, which is pretty typical in translations. Okay, let's take a look at a couple examples. Okay, let's take a look at the first example. So this is just asking me in plain language to translate this shape up 3, left 4. So to do that, I'm just going to pick a point, in this case the top one. I will count up 3, 1, 2, 3, then over 4, 1, 2, 3, 4. Taking my first point from 4, 5 to 0, 8. I'm now going to do that with my other points. I could do them individually. 1, 2, 3, 1, 2, 3, 4. Then 1, 2, 3, 1, 2, 3, 4. Recreating the shape in a different place. The shape is congruent to the original shape or the pre-image. So that's basically it. That's what a translation is. The only other thing we could explore in the next examples are the different notations that we use. So let's go take a look. So this is the same translation as in the previous example. This is just using a different notation that's pretty common amongst translations. And what it's essentially doing is to subtract 4 from the x values of the coordinate, or in this case, move it left 4, because our x values of our coordinate move our coordinate horizontally. Then the y value, we add 3 to that, so that would move it up because our y value of our coordinates move up and down. So if you don't have a graph, what you could do is, let's say you're given the point for 5, I could subtract 4 and add 3, creating that point that we saw earlier. It's a pretty common standardized question for somebody to do, asking a student or somebody to do a translation without giving the graph. But essentially, you can just create the 3 points here on paper, then just plot them. Or if you like, you could just count them as we did before. And they're going to end up exactly the same. It's just another way to do the same thing. Alright, let's take a look at the next example. For this example, we're back to straight language here, or plain English. And this example is telling me to translate the shape down 4, right 2. What I am going to do is, I am going to just move 1 point this time, then use what I know about rigid motion to move the other 2. So I know 2 things about rigid motion. 1, the lengths of the sides will not change. 2, the sizes of the angles will not change. Lastly, because this is a translation, I know that the orientation of the shape will not change either. So in this case, the triangle's pointed up. Wherever I move it on the graph, it will remain pointing up. So I'm going to choose a point that I think is easy for me to orient the other 2 points to. I am choosing this one. You could choose either point, whichever one is easiest for you. I'm going to move this point down 4, 1, 2, 3, 4, and over 2. Okay, well now I recognize that my other 2 points are relative to this point. So, for example, I recognize that this point here is just 2 to the right of the point I moved. So, I'm going to move that point. Now what I recognize is that from this point, I can count up 1, 2, 3, and 1 right over, and that's how I could recreate that point on my other triangle. So I'm going to count up 1, 2, 3, then 1 over, and I made that point. A little bit quicker than counting the points individually and moving them, but if you have a difficult time orientating with orientation in these shapes, the easiest way to move these shapes or translate them is 1 point at a time. Alright, let's take a look at the last example. The last example uses what's called vector form. So this is vector notation. A vector is usually a line that portrays magnitude and direction, and what we're doing here is we're using that format to translate these figures. These are written very similarly to coordinates, where this is xy and this is xy here. They're both saying the same thing, but they're just different forms of the same notation, and I just feel the need to share that. The brackets here, in this case, are making clear that you are working with a vector. So now I'm just going to move this shape exactly as I did before. So I'm going to move my points 2 to the right, then 4 down, to put me about here, and I just recreate my shape as I did before. And that's it for translations. There's piles of videos out there on how to do these, and I even have a couple myself. I hope you guys found this one helpful.